Hi friends, today we are starting a very interesting topic, that is biostatics and research methodology. If you know the concept like that, it's very interesting, and if you know the terms like that, we can correlate with each other. It will be helpful in our research methodology journey. The first thing we will come across in research methodology are different chart. So the first one is pie chart, which is very common. It is like a circle chart. It's a way of summarizing a set of data, or we will call it as a set of nominal data, or it will display the different values of a given variable. For example, here we can see the thing, right? Example, percentage distribution. So from this part or from this pie chart, we can find out this green color thing 50% is more. So this type of chart is a circle divided into a series of segments, and each segment represents a particular category. Next term is bias. In research, bias occurs when a systematic error is introduced into a sampling. Means it's a set of numbers. Okay, so when a systematic error is introduced in a sampling or by testing, by selecting or encouraging one outcome, means we are expecting one whatever the result, that is outcome. So that is the bias. So this bias can occur at any phase of the research, including the study design or data collection, as well as we can see the thing in the process of data analysis as well as in publication. Then another we are currently using other term is probability. Probability means chance, simply if you are telling. So we can tell the probability is a sampling method that randomly select from a small group or from a larger population. Means from a larger population, if 100 people are there, we are taking in that this 20% may pass. That is the probability or chance. So the researchers predict the likelihood that the response will match those of the population, that is probability. Next term is degrees of freedom. Means we are allowing the data points in a sample to be randomly selected except for the final value. So normally when you are telling degrees of freedom, we have to know what is the number of unit within a given set minus 1. For example, if n is the sample size, we have to tell the degrees of freedom for that is n minus 1. So the sample size does not matter as long as the last data point in the sample until it remains constant. That is degrees of freedom. So we can see where n minus 1 like that, we can correlate with the degrees of freedom. Next one is chi-square test. Chi-square test means it's a statistical test to compare the observed result with the expected result. It's just a comparison where our data is we are comparing with the expected result. That type of test we will call it as chi-square test. So the purpose of this chi-square test is to determine if a difference between the observed data and the expected data is due to a chance, or if it is due to a relationship between the variables you are studying. Variable means which are the thing we are keeping, what may be the more chances for getting one result. So that thing we will keep it as variable. So we will get a comparative result in the chi-square test. Sign test. Sign test mean it, yeah, same thing here also we are comparing the paired observation when the data if not satisfying with our assumptions for the parametric test. Normally the sign test we are using in a situation where sample size is small or when the data are skewed. Means if the number of data, if you are only giving 450 100 like that, we can use this sign test for a comparison method. Intervention study means these are clinical study in which participants are prospectively assigned to groups. Means we will tell them what may be the thing, or we can give them placebo, means no intervention, means without knowing what the thing we are having that case we will call it as placebo, so that researchers can evaluate the effect of intervention on the biomedical or health related outcome. Such studies or clinical studies where participants are prospectively assigned to groups, such things is known as intervention study. This is another term we can see different patterns in research methodology. This is the normal distribution pattern. Means you can see the this type of curve is known as what normal distribution curve. Here we can see the most value cluster around a central region with values are tapering on the both side, right? So the measures of central tendency mean we will here use the terms mean, median, mode, etc. are exactly same in the normal distribution. So we will get like normal distribution or bell-shaped curve is an example of standard normal distribution pattern. Next term is Wilcox rank sum text. Means we are ranking the observation like Na plus Nb of the combined sample. Means whichever thing having smallest rank we can give for one number and second smallest rank two and all because we are ranking or we are putting some numbers or A or B for the observation. Such sum test is known as Wilcox rank sum test. Next concept is multiple regression. Means it's a statistical technique that analyze what is the relationship between the two or more variable and we will use this information to estimate the value of the dependent variable. So in this we are describing the dependent variable to more than one independent variable. So we are correlating the independent with dependent variable. So this is the normal equation we are using for the multiple regression equation, that is y is equal to a plus b 1 into 1 plus b 2 into 2 plus etc. up to the last independent variable where this x1 x2 like that are the independent variables, so up to xk is there. This is one statistical technique to analyze the relationship. Next part is 2 square and 2 cube design. Means it's a 2 factor factorial design. So we can call it as an experimental design where data is collected for all the possible combination having two factors, that is 2. And 2 cube means we are giving three input factors that change on the 2 level. That is level is 2 and whatever we are giving input will come as superscript or power. Okay, so we told the 2 power, 3 power like that. So what do you mean by a power of a study? Power of a study represent the probability. We already told chance, right? The probability of finding a difference that exists in the population. So we will design whether I have to go for 2 power, 3 power, etc. So it depends on the chosen level of the significance. So which is the significant factor or which may be the determinant or variable we have to decide. So based on that, we have to check the size. Whether I have to go for 2 square design, 2 cube design, etc. Student t-test application means we are using this test to compare the means between two groups, whereas in ANOVA we are using to compare the means among three or more groups. So here we are comparing between two groups. In ANOVA, first we will get a common p-value and based on that we will tell. Here also we are telling whether the values are or mean the mean difference is statistically significant. Coming to the confidence interval. Interval means like it's a range of value we can expect while you are telling maybe this percentage it will come or when you are experimenting again this value have to come or resample. That interval is known as confidence interval. Standard error of means or capital SEM. So this is the formula we have to follow. Standard error mean SEM is equal to SD divided by square root of n. Means it is equal to the ratio of standard deviation to the root of sample size, where SD means standard deviation and capital N means number of observation. This is the equation we have to follow. Next term is control space. So it is an available region about a current or chosen set of value. So this is the available region. For example, if you're keeping two variable v1 and v2, when we are putting the inputs or operating thing xy, this thing will come in the available region x and y. Inclusion and exclusion criteria. So this is a normal thing we are using if we are doing the research methodology or if we are doing clinical studies like that. So inclusion means which are the factors such as type, stage, age, sex which can be included for our study. So maybe we will remove this category, this age category, sex category, whichever we can be included as factor, that is inclusion criteria. Whereas exclusion means this thing have to be means this age category have to be removed or have to be changed when we are doing this current study sample. That is exclusion criteria. Next one is very common thing. It is a graphical representation known as histogram. So it's a graphical representation of the distribution of data where we can see a set of rectangles, right, adjacent to each other, and each bar represent what is the kind of data. So from this we can clearly understood like 700 hours like that we can see more in that lifetime we can see more number of lamp. So we will get an idea by seeing this rectangle which one is having more effect. With this we are winding up this session. See you again. Bye.